Programming Part 1. Section 2.5, Sequence Statements. Okay, so we're going to actually write our first program. Okay, so we're going to write a program that computes and prints the area and perimeter of a rectangle given its length and width. So remember, we are not using any official programming language. We have to keep it generic. So the Praxis uses a pseudocode. We will be using pseudocodes. You will not be able to go compile this or interpret it in an IDE. When you start the program, there's some questions you really want to think about. And these are good. Like if you're teaching it and you're starting programming, always think about what kind of input should we have? What kind of algorithms should we have, like formulas? What are our outputs? What should we display to the user? So these are just some questions, bubbles to think about. So what variables should we declare? Okay, so again, what should we kind of start with? What data types should we use for those variables? How do we actually compute the area of a rectangle and the perimeter of a rectangle? So again, those are like formula implementations. In this example, we need to know the length and width of the rectangle. They need to be numeric. And we would probably want to use floating point types because the length and width of a rectangle, it's not always whole numbers. We can have 1.5 inches per a length or width. So we would probably want to use float for all of this. So that answers the variables and the data types. Computing the area of a rectangle is length times width, so they would need to know that. Perimeter is 2 times length plus 2 times width. So those are all formulas they would need to know. Those are like your algorithms. Okay, so this is us just kind of setting it up. Now, I didn't actually specify the length and width of the rectangles, so I just kind of made one up. Like I used 5 and 10. So, if you wanted to be a little more, like you could do like 5.8. If you really wanted to show students that, hey, we could use floating point types for this. I did declare them as float, so I have a float length and a float width, and then I assigned them here. You could do this all in, like together. You could do float length, like, again, this is just an example here, but you could do like float length. Okay, so that's declaring length variable as a floating type. And then you could assign it whatever value you want. A lot of times in practice, instead of actually assigning a value, what they'll have is like an input, maybe like an input function. What that'll do is that'll just let the user input their own values. So if you ever see that, that just means it's getting a user input. Okay, so this is kind of hard coding it to a value. This is a little more dynamic using a user input. But anyway, so you could do this assignment in one line. Okay, so that's kind of the first thing. It's like defining your variables, saying, okay, these are what we have. This is what we need to know. The next part of that algorithm, of course, is the actual computation. So again, you're trying to compute area and perimeter. Both of those would be float. Area is length times width. Perimeter is 2 times length plus 2 times width. These are the formulas for area and perimeter of a rectangle. And then lastly, generally just computing that isn't good, right? We want to show the user the outputs. So we can use a print statement to display output. This is an example here. So, instead of just doing print area, okay, so like if you do something that just prints area, it's just going to print the output, like the numerical output. And that's fine. That might be, good enough. But a lot of times you want to let the user know what they're printing. So this is kind of a format print that we can do here. So the quote means it's going to print the string. The area is. So notice that's in quotes, so it will actually print those words. And then this plus symbol, so in math, when we see a plus symbol, it means to add numbers. Well, in programming, when you add something to a string, you are what we do, it's called concatenating. Okay, you're creating a larger string. You're joining strings together. So what this is going to do, it's going to print this string, and it's going to print the area. Okay, so if the length is 5 and the width is 10, the area would be 50. So it would actually print out this to the user, which is a lot more useful than just printing 50. Okay, they're like, okay, I got 50. What is that? So a lot of times in good programming, our print statements typically have some text to kind of let the user know what the output is supposed to represent, and then it'll actually output the results of the program. For this one, it would print out the perimeter is, and then let's see, that's 2 times length is 10, plus 2 times 10 is 20, so the perimeter would be 30 here. So it's actually going to, notice area is not in quotes here. If you put area in quotes, it would actually print the word area. We don't put quotes around this because we want it to print the actual value of that variable. Okay, so that's called concatenation. Sometimes with programming, you have to kind of worry about pre and post conditions. A precondition is just a condition that must be met before you implement your algorithm. So some things that you may want to be careful of: make sure you're not dividing by 0 because that will give you an error. Make sure if your user is supposed to be inputting a number and they input their name, that's something that you may have to check for or fix. Make sure to not take a square root of a negative value. Some languages will actually do complex numbers, and then some languages will not. Some languages, if you try to take a square root of a negative, it's going to error out on you. So those are things that you just want to make sure kind of are set up before you go into an algorithm, because they could cause issues. They could cause errors with the errors with the output. Post conditions are just at the end of the code, like basically once the algorithm's been run, what do you expect to happen? For instance, let's say you had an array and you ran an algorithm to sort it. Then the post condition would be that the elements would be sorted, and most of our sorting algorithms by default are ascending order from smallest to largest. But that would be a post condition. That's what we expect the output of the list to be at that point. Maybe just the output is a number. Okay, kind of like what we did earlier with perimeter and area. The outputs were numerical values. They were floating point values. For numerical methods where we're trying to kind of, not really guess, but approximate a solution, we sometimes have to create an algorithm that will approximate a solution within a certain tolerance. So you're like, this is the value within 6 decimal places or something like that. That's a post condition because that's something on the output of the data. All right, so here's just a little example. For this one, notice I used a get function, and if I ever use any kind of functions, it should be explained in the instructions what that function represents. So this function represents just a user input. Okay, so I used input earlier, get. Every language has a different thing. It's just kind of defined in the language. So that should always be explained in the instructions. So here we're going to get a user input. We're going to multiply this 2 times x plus 5, and it's going to print y. So the precondition, we're assuming that they're going to input an integer value. Okay, that's because of the data type being set to int. That's kind of our precondition. If they don't, we're probably going to get an error. If they inputted a floating point and we define it as an int, it'll probably just cut off the decimal. So like if they input 6.5, we would just get 6. However, if they input a string, like if they input the name, Harold, that's gonna create an error in all of our code. Okay, so that's gonna be a big issue. Post condition. The post condition is just kind of what's happening to our output y. Our output, so our input's being doubled and then summed with 5. Okay, this is a linear function, so our post condition is just, it's a linear transform really of that input. Okay, so it's being doubled and then summed with 5. It is a numerical output. Okay, so that's another post condition there. It will be a numerical output. Will it be a float? Probably not, being that we had x be an integer, so this really should be an integer here. Causing this to be a float isn't going to really change the fact that we're really only going to get integer outputs here. But it might, what it might do is, for instance, let's say the user inputs 7 for x. All right, and this would do 2 times 7 plus 5, which is 14 plus 5, which is 19. So what happens is if we say y should be a float, it might print, depending on your language, it might just put a 0.0 behind it. Basically, it casts this integer as a floating point number. It's the same number numerically, it just might be formatted, it might look a little different when you print it.